Subscribe to AmpCode and ring the notification bell to get the latest content.
Okay, so now let's start with the transformation as well as the action in Apache Spark and what is the difference between them. So basically, as the name suggests, transformation is nothing but they are operations which we do on top of any RDD or dataset or even data frame that returns a new RDD or data frame. Because as you already know that RDD or data frames are immutable, which means that you cannot change them after you created it. So for that purpose you have to create a new RDD or data frame from the previous one using the transformations. So the examples of the transformations are nothing but like map operation, filter operation and reduce by key operation, which we are going to see in the subsequent topics. So let's talk about the action now. So basically action is nothing but which triggers that computation and returns us the actual result. So transformation will just return a new RDD or data frame from the previous one, but the action itself will trigger the computation and will get the results of the data frame. So this has like many operations. So this has like many actions like count operation to get the count of your data frame or RDD. Then we have the collect as well as save as text file to save your data frame or RDD as a text file in your storage solution. So let's talk about the transformation in detail. So as you already know that transformations are nothing but the operations on top of the RDD, data frame or the data sets, and it produces a new distributed data sets from the existing one. Since it is not immutable, you have to create a new one with the help of the previous RDD or data frame. So they are generally lazy. So we are going to talk about lazy evaluation also. So lazy evaluation means that they are not executed immediately, but they will create a logical execution plan. So what it means is once you apply any transformation and return a new data frame or RDD from your previous one, it will not get computed immediately by your Spark cluster. It will need some action to be called for triggering that execution or triggering that computation process, because transformation will need a lot of compute on your Spark cluster depending upon the size of your dataset and the type of transformation you are applying on that dataset. So basically lazy evaluation will only create a logical execution plan, and it will give, and Spark will provide us the most optimized execution plan to be able to kick off when we call an action. So lazy evaluation means that transformation will not do any computation, it just creates a logical plan for your execution, and once you call an action, then only all the groundwork and computation will happen on the Spark cluster and you will get the result. So like there are different types of transformation. The first one is the map transformation. So basically this map operation is way more popular in the RDD API, which is the core API of Apache Spark. So it applies a function, so you can pass your predefined function inside the map to each element and it will produce a new RDD. Or else you can also provide a map function to data frame or dataset as well. Then we have the filter operation, which is way more often used for filtering out your data. So filter will select the elements that you require and you can apply as many as condition as you know, which we can do using SQL where clause. So that you can use inside the filter operation or the function to able to satisfy some specific given condition and create a new RDD on top of it. Then we have the group by for aggregating your results based on some key. So this group by operation is also similar to the SQL operation. So if you know SQL and if you know how to manipulate and get the meaning out of the structured data, you will able to understand all this transformation, and we are also going to see them in the subsequent hands-on tutorial. Then we have the join operation. So join operation is pretty crucial operation, and once you get started in your project, you will often see that there are so many data sets that are available coming from different sources, and you have to join all these data sets to get the aggregated output, or we can say the combined output as per the logic and the output that you required out of your data solution. So for that, it will combine these two or more data set based on some common key. So let's say if you have an employee data set, so you will be having like employee table, the salary table, as well as the department table. So the common key is basically what is common between all these tables. So that could be the employee ID, which is a unique identifier for every employee. So basically on the basis of that common key, which is employee ID, you will able to join all these data sets together to make a sense of your data and do some analytics on top of it. Now let's talk about the narrow transformation and the wide transformation. So this is also often asked in the data engineering interview. So basically narrow transformation means that if you input an RDD and each partition of that RDD will contribute to only one partition of the output RDD. So there are so many transformations like the map transformation, then the filter transformation, in which if you apply those transformation, your one partition of the input RDD will only contribute to a single partition only as an output RDD. But in case of the wide transformation, it can contribute to multiple partitions of the output RDD. So there are so many transformations like the group by key, reduce by key, as well as the join operation, which needs to shuffle your data between the partitions to be able to apply that transformation, and at what cost. Your each partition of the input RDD have to contribute to these multiple partitions of the output RDD. So this is what the difference between the narrow transformation and wide transformation, and you have to choose the right kind of transformation for your solution to improve the efficiency as well as to optimize the whole execution of your Spark application. So this is all about the transformation. Now let's talk about the action now. So as we already know and we have seen in the introductory part that actions are nothing but the operation which triggers the computation, the actual execution of the transformation, and it will return some value to the driver program, or we can say we can write the data to some external storage system or the native storage system of Apache Spark. So basically action we can say that it will trigger the computation plan or the execution plan which is provided by Apache Spark when we apply some transformation on top of it. And due to lazy evaluation, it is not immediately computed, but it waits for an action to take place, and all this computation which has already fixed and in place using by the Spark cluster will get executed and distributed across the cluster of the worker nodes. So this is how action works. So there are like different actions that are available to get the count of your RDD or the data frame or data set. This is just an example. So as you already know, these are the operations that actually initiates the computation, and we have to also talk about the eager evaluation. So actions are nothing but the eager, and it leads to the execution of entire transformation lineage. So let's say you have the input data frame and you have maybe created 7 data frames with different execution on top of one another. So your final data frame will have to compute the whole transformation that you have applied in the earlier stages, because as you already know, data frames are immutable. They cannot be changed. So for applying transformation, you have to create a new data frame or RDD, and it can create several RDDs or data frames in your code. And once you call an action on the final data frame, it has to run the whole logic and the execution plan under the hood. So that is how eager evaluation will work. And if we talk about some of the examples of the actions, as you already know, there is a collect operation which retrieves all the elements of the distributed dataset to the driver program. Then we have the count operation, which will give us the number of elements which are present in your dataset or data frame or even RDD. Then we have the first operation, which returns the first element of the distributed dataset, which is nothing but the first row. So this is pretty similar to head operation in the pandas data frame, if you know what I mean. And also we have the save as text file. So this operation will write your content of the dataset into some text file in some specific path or maybe some external data source. So basically there are several actions like the data frame.write operation, which is nothing but writes your data frame to as a different format in some external data source, or maybe HDFS if you are using Hadoop distribution system in your organization. So this will write your data, and you can also define the format, in which format you need those files. So you can choose either CSV or JSON or Parquet depending upon the use case that you have and the type of data that you're going to handle. So these are like some of the examples of the actions, and we are going to see them as well in the subsequent lecture, where we will see the hands-on tutorial on our transformation and the action on top of our data frames. So what are you waiting for? Let's get our hands dirty and start working on the data frame operations as well as the actions on some sample data sets. So I'll see you in the next one.
So that's it for today. I'll see you in the next lecture.